Okay guys, so we have done few questions of exercise 5.2 in our previous videos. So now again we are continuing with the chapter of arithmetic progression, exercise 5.2, and we are on question number 13. So we are supposed to do that. Now they say how many 3-digit numbers are divisible by 7? Okay, so now first I have to find the AP, the numbers divisible. So what will be my first term? So first term of 3-digit numbers is divisible by 3. So then I'll keep on adding the 7. So after 100, right? So after 100, 101 doesn't go by 7, 102 doesn't go, 103 no, 104 no, 105, right? So my first term of this AP will be equal to 105, right? And then 7 will be added, right? So subsequent terms. So my T1 will be equal to 105, and I know my D is 7, right? Because I am adding. So my T2 will be equal to A plus D, right? So that would give me 105 plus 7, and then T3 will be equal to A plus 2D. So this will be equal to 100, and this will be 112. Okay, so this will be 100 and plus 7 into 2. So this will give me 105 plus 14. So this will be 119. So this keeps on going like that. So now I know my first three term. So I would say my AP is equal to 105. Then I have 112, 119, and so on. But then I have to find the last term also. So from 9999, so largest possible number, right? So largest 3-digit number. So this would be the smallest fit. So my largest 3-digit number is equal to 999. But does it go by 7? No, it is not going, because we are getting the remainder. Either you check by dividing it by 7, so which will be below. So 998, 997, then 996, 995, 994. So one will come. Or you can do, you divide this by 7. So if I divide 999 by 7, what will I get? I'll get 994, right? 994 will be my number. Okay, but if I divide this by 7, I'll get 7 times 1, then 29. So 7 4 times 28, 19, and 2 times 14, right? So 142 I get, and then my 5 is my remainder, and by 7, right? So that's fine, 5 is my remainder. So then I can subtract 5 also, because this 5 is my remainder. So I can subtract. So either I can do 999 minus 5. So I get 994 as my last 3-digit the last 3-digit number which is divisible by 7. Okay, so my last term of this AP is equal to 994. Okay, so now I can write down my AP. So AP would be will be the last term I can write down. Okay, 994 is last term. Now AP would be my 105, 112, 119, and up to 994. Okay, so that means I have to find how many digits are there from 105, terms are there from 105 to 994. So my, let it be in nth term, we know. So now we can say that this is my series. A is equal to 105, and my D is equal to 7, and my last term, so Tn is equal to 994. So I have to find n, because I have to find how many numbers are there, right? So divisible by 7. So that would give me, if I find out n. So my Tn is equal to A plus n minus 1 into D. Now Tn I know is equal to 994. A I know is 105, plus n I have to find out, and D is equal to 7. Now this 994 minus 105, or I can first multiply and then see. So 105 plus 7n minus 7. Okay, so 994 is equal to 105 minus 7 would give me 98 plus 7n. Okay, so 7n is equal to 994 minus 98. Okay, now this would be 4 less than 900, so 7n is equal to, so 896, right? Okay, now 7n is equal to 896 by 7, so 7 times, and 7 2 times 45, 7 8s are 56, so that I get. So that's fine now. So now there are, so answer I can write down that there are 128 three-digit numbers which are divisible by 7. Correct. So you can see similar type of questions can be there. How many two-digit numbers are there which are divisible by 3, or anything they can give. So I think you should be able to do. So now question number 14 is also similar to the previous one. There we had found out multiples of 7, and here we have to find the multiples of 4. Okay, so now they say how many multiples of 4 lie between 10 and 250. Okay, so now to find my AP, so multiple of 4, first multiple of 4. Okay, first multiple of 4 greater than 10, that would be equal to 12, right? So because 8 and then 12, so I can write down this. Now because I know this 12 and common difference will be equal to 4, and then this previously I told you that 250, so just divide 250 by 12 to find the multiple of 4 which is just less than 250. So what will I do? 250 by 4 I'll divide. So what do I get now, guys? So 4 6 times, and then 10, so 4 2s are 8, and 2 will be my remainder. So I'll just subtract 2, so it will be completely divisible then. So 250 minus 2 will give me 248. So that will be my last multiple, right? So just before 250. So these will be the multiples. So my A will be 12 and my last term will be 248. So my AP will be, and we know D is equal to 4. So AP would be equal to 12, then adding 4 to it, so 16, 20, 24, so on, and my last term is 248. Okay, so now how many multiples? So I have to find n again with the last term. Okay, so now looking at this AP, A is equal to 12, D we know it is equal to 4, and my TN is equal to 248, and I have to find the n. Okay, so now I'll write down the formula. Tn is equal to A plus n minus 1 into D. Tn is given as 248. A is 12 plus n minus 1 into 4. Okay, so now 4n minus 4 is equal to 248 minus 12. So 4n minus 4 is equal to 632. Now 4n is equal to 436 plus 4. 4n is equal to 240 by 4. So 460. So there are 60 terms in this. Okay, so we can write down the answer now. So my answer would be, there are 60 multiples of 4. 60 multiples of 4 between 10 and 250. Okay, between 10 and 250. Okay guys, so let's move to question number 15. Question number 15 says, for what value of n are the nth terms of two APs So my first AP is 63, 65, 67 dot dot dot, and another AP is 3, 10, 17, and so on. So these are my two APs given, and I have to find that what will be the, for what value of n there some nth term will be equal. So let's me go to the solution. So my I'll take first AP first. So for first AP, okay, my AP is 63, 65 and 67 and so on. Okay, now so from this AP I know my A is equal to 63 and my D is equal to T2 minus T1 term second minus T1, so 65 minus 63, so that is equal to 2. Now I have to find the nth term, so I find in the value of n, so my Tn is equal to A plus n minus 1 into T. So nth term will be equal to A 63 plus n I have to find out, and my D is 2. So this equals to 63 plus 2n minus 2. So then I get 63 minus, so 61 plus 2n. This is my nth term. So my first equation, right? Okay, now I'll move to my second equation. So my second equation would be for second AP. Okay, so for second AP I know what it will be. Now what is my second AP? Second AP is 3, 10, 17. So 3, 10, 17 and so on. Now I know A will be equal to 3 and D will be equal to second term minus the first term, so 10 minus 3, so that is equal to 7. Okay, now again the same formula, Tn formula, right? So my Tn will be equal to A plus, so 3 plus n minus 1 into my D is 7. I can substitute this as 7. So this is equal to 3 plus n minus 1 into 7. This equal to 3 plus 7n minus 7. So this gives me 7n minus 4. So that is my second equation. So from this equations, now both of these equations will be equal, because they are saying in the question that there is some value of n whose nth term will be equal. Okay, so now I can write down that my first equation should be equal to second equation, right? So therefore first should be equal to second, because nth terms of APs are equal. This is given to us, so I can write down this way. Now first equation is 61 plus 2n. 61 plus 2n should be equal to 7n minus 4. Okay, now let's solve it. So I'll take 2n that side and this. So 61 plus 4 will be equal to 7n minus 2n. So 7 minus 2 is 5, n is equal to 65. So n is equal to 65 by 5 and this gives me 13. So I know my 13th terms of both APs are equal to each other. So I can say 13th terms of both APs are equal. Right? See you in the next video for next questions.